Good morning, Math A. This is Miss Espinoza. We're going to be doing lesson 7.2D. So if you can have your PDF out, you printed it or do it electronically or a piece of paper, then we'll go ahead and start. So today we're doing our funky shapes, or shapes that have two parts in them. And we're going to find surface area and volume. So here, number one, find the total surface area for the solid shown to the right. So I have to think about surface area. I have to think about all the different sides that I have. Okay, so when I look, my base is really that funky shape. So I have two sides that look like this, kind of a big fat L. Okay, I've got two of those. And then I look at the top. On the top, I have a rectangle that is 2 by 4 right here. And then I have another section right here. And if I look at that dimensions, I know that this whole thing is 7 across, and that was 2 across. So over here, this has to be a 5, and this is still a width of 4, so this is 5 by 4. And then I'm going to look for some more colors here. Okay, I have one little rectangle in here that did not change my color at all. Okay, and that rectangle is 2 by 4. Okay, I already took care of the front and the back. I got 2 of those guys. Okay, then I have to think, where else am I going in this shape? I have this along the side, and I see that that one is 4 by 4. And then I got to think about what I don't see. So if I turn the shape around, if I went 3D here, I have this left side back here, and we have to figure out this right here is like the 4, and this is the whole height. So I have to add 4 plus 2, so that's 6. So I have another one that is 4 by 6. And then I can't forget about the bottom. That wouldn't be good. So over here I have a bottom. And that bottom part is 7 by 4. Okay, so I have a front and back. This one I'm going to have to work on. There's 2 of those. Then going around the shape, I had 1, 2, 3 on top. 1, 2, 1, 2, 3 on top. I had this one on the right side and this one on the left side, and I had this one on the bottom. So we have to do a little work to get to this weird funky shape. So I'm going to cut it up. You could surround or you can cut it up. And when I see this is 7 by 4. And over here, this little guy is 2 by 2. Okay? So here, this would be 4 and this would be 28. So altogether I've got 32, but then I got to times that by 2 because I got 2 of those. So for this area, I got 2 times 32, which is 64. And for this rectangle, 4 times 2 is 8. And for this rectangle, 5 times 4 is 20. And for this rectangle, 2 times 4 is 8. And then down here, for this rectangle, 4 times 4 is 16. And for this one, 4 times 6 is 24. And for this one, 7 times 4 is 28. Then I need to take my calculator and add those all together. So 64 plus 8 plus 20 plus 8 plus 16 plus 24 plus 28. I get a grand total of 168 centimeters squared. Okay, so you have to kind of visualize and draw things out. A lot of different colors will help you, so it's good to have your color pencils out while you're doing math. Number 2, a birdhouse was built as shown below. There are 2 circular doors, one on each side of the triangular faces with a radii of 4. What is the surface area of the birdhouse rounded to the nearest hundredth? So on this one, I like to Pretend like I have everything sealed up, and then I'm going to take out the circle. And I have to remember there's a circle on the front and there's a circle on the back. So I'm just going to do it for a triangular prism. So the triangular prism has two bases. These guys, I'm going to pretend like they're solid. I'm not going to worry about the circle for a minute. They're 24 by 7. And there's two of them. Two of these guys. And then I have my three sides. I have a rectangle that is 12 by 25. That's my hypotenuse rectangle. And I have my height rectangle. That's back over here if I did it 3D. That is 24 by 12. And then I have the bottom. I can't forget about the bottom. It's 7 by 12. Okay? But then we're going to have to remember that we have a circle on the front and back that we have to subtract. So we have to subtract out two circles. And my circles have a radius of, it said 4 feet. So two circles with a radius of 4 feet. So now I can go calculate my work. So over here, I'm going to go 2 times the base times the height divided by 2 because it's a triangle. So essentially, my two 2's cancel out. So I really have 7 times 24. Which is 168. I'm going to write that down here. Then I have this one. I have to go 12 times 25. I get 300 for that. And then for over here, I'm going 12 times 24. I get 288. Then I have 7 times 12, which is 84. Then I have to subtract out my two circles. So circle, I have to remember the area of a circle is pi r squared. So r squared, 4 squared, 16. So I have 16 pi. So I have 2 times 16 pi, or 32 pi. And I'm going to multiply. I'm going to use 3.14 for pi. So that's about 100.48. So minus 100.48. Then I'm going to put all my numbers together. And again, this is approximate because I had to use pi, and I estimated it as 3.48. This goes around to the nearest hundredth, so we'll go there. So 168 plus 300 plus 288 plus 84 minus, because we got to take out the circles, 100.48. And I get about 739.52. And we're in feet, so feet squared. Again, for pi, I use 3.14. Okay, next one. A cat stretching post is pictured below. Find the volume of the base and the post in cubic inches. Okay, so I'm going to find the volume of the first one, and then I'm going to add it to the volume of the second one. Not so bad. For the bottom, we know we just have to multiply the 3 dimensions. 1 times, we have to pay attention. This one got tricky because we had to look at the units, because this says feet and this says inches. So first we have to go back and we have to pay attention. So what are we supposed to be getting it in? We have to read our directions. They wanted it in cubic inches. So we got to convert our feet to inches. So I'm going to go ahead and go back and look at where I had feet and make those inches. So 2 feet, 2 feet. There's 12 inches in a foot. So this has to be 24 inches. And over here, these are really 12 inches. Okay, so this problem is not tricky by its work, it's tricky by its conversions. So now we can work out this bottom part. This bottom part, I'd have to go 12 times 2 times 12. That is 288. And on this top part, I'd have to go 4 times 4 times 24. $384. And then I'm going to add my two numbers together. So I get the volume is equal to 672 inches cubed. Okay, on that one we had to convert our inches. Okay, next one. Find the volume of the solid. So first thing I'm going to do is I'm going to treat it like it was completely filled in. So I'm going to first do a rectangular prism, and then I'm going to subtract out the triangular prism. So I'm going to do my rectangular prism minus that tiny triangular prism. Okay. So to find the volume of the rectangular prism, I just have to multiply the dimensions. 9 times 8 times 8. For the triangular prism, I have to multiply the area of the triangle. So I have to think about this. If this whole thing is 9, and that is 3, and that is 3, then my base over here has to be 3. So the triangle's base is 3, and the triangle's height is 2.6. And because it's a triangle, I have to divide by 2. But then I have to multiply by the height of the prism. The height of the prism is the distance between the two triangles. So the height of the prism is still an 8. So here I have to multiply by the 8. Okay, so now multiply my numbers. For my rectangular prism, 9 times 8 times 8, I have 576. And then I'm going to subtract off the triangular prism because I counted it when it didn't really exist. I get 31.2. So then I subtract those. And I get the volume of my composite function is equal to 544.8 inches cubed. So again, remember, sometimes you can surround subtract, sometimes you can cut it up. It just kind of depends on your preference. On this one, surround subtract was easier. That's why I went that way. Okay, we are done with this lesson. So go ahead and start your homework.